Namaskar friends, myself Dr. Ashwini Kumar Gupta. Today we will continue our series of General Organic Chemistry, lecture 7. As you remember in class lecture 6, we have done some few examples of UPSC nomenclature pertaining to specific functional groups, like acid, ester, acyl chloride and different. So for more information you can visit my previous lectures. Okay? Today we will do the last part, the penultimate part, the last part of the series, our series, which in which we will see the IUPAC nomenclature of aromatic compounds. Aromatic compounds. As you know, aromatic compounds basically are nothing else but six-membered or five-membered or four-membered or three-membered or more than six. But the primary, the basis which IUPAC has considered as the basic thing is six-membered ring. As you see in the previous lecture, I had shown you benzene looks. This is the pi bond, sigma bond, pi bond, sigma bond. That means it has a conjugated bonds, conjugated alpha and sigma bonds. Sorry, sigma and pi bonds. That is double single. Plus, it contains delocalized electrons. Delocalized electrons. Okay. Now, for benzene, take for example, this is 1H, this is 1H. Now, since it is delocalized electron, that means the electron is moving throughout the ring. So it can be either represented by this form also, as per IUPAC. Okay? Now, so cyclohexane 135 triene, because there are three double bonds. So ene, 1, 2, 3, with 1, 2, 3, 4, 5 and 6. So 135, cyclohex 135. Okay? Cyclohex 13 triene. But now IUPAC has considered as a general name like benzene, which is a universally accepted. Benzene. Henceforth we will nomenclature. Henceforth we will call it as benzene. Unless and until we are specifically mentioned in terms of, suppose a question comes in your exam that whether this benzene, what is the IUPAC name of benzene? Suppose, then you will have to write it is cyclohex 135 triene. Fine. Now, similarly, I will take one example. Take for example, this nomenclature is comparatively much more simpler than our previous nomenclatures. Take for example, this is bromine. So this will become 1, 2, 3, 4, 5, 6. So I will say bromobenzene. Bromo means it's, if I've written just only bromo, that means understood it is at first position. Bromobenzene. But suppose if I write here bromo, and then here if I take for example, if I write here NO2. Now considering from where the name will be starting. Now this is bromo and this is nitro. The prefix. Now we have to see, it's important from where we will start, whether we will start from here or from here. Now see, alphabetically B comes first and then N because both are substituent basically. So this has to be 1, 2, 3, 4. So it will be 1 bromo, 4 nitrobenzene. 1 bromo, 4 nitrobenzene. We'll take another example. Take for example, this is bromine, this is chlorine, this is nitro. Now, as you have seen in previous lectures, the branching has to be given first preference over alphabetical order. So if I see here, although it is bromo, this is chloro and this is nitro, but I can't start the counting from here 1, but I'll have to start it from here 1, because the next immediate branching is at position 2, 3, then 4. So, but while naming, I'll have to go by alphabetical order. While numbering, I will start from chlorine, then nitro, because the immediate branching is after chlorine, immediate branching. While if I go from bromo, then there is the branching is at the third position, but here the branching is at second position. So it happens to be 4 bromo, 1 chloro, 2 nitro, 2 nitro benzene. Fine. 4 bromo, 1 chloro, 2 nitrobenzene. Fine. Now, see, one more thing. Suppose here there is 1, 2, 3, 4, 5 and 6. So it is 2-methyl either you can say 2-methyl toluene, because CH3 and C6H5 ring and CH3 is known as toluene. Either you can write 2-methyl toluene, or you can say 1,2 dimethyl benzene. Dimethyl benzene. This also is a IUPAC name. 2-methyl toluene or 1,2 dimethyl benzene. In this case, I have taken benzene as the parent, and then CH3 and CH3 are the two substituent. And in this case, the complete whole this part, this toluene part is the parent, and this methyl is the, right? You can name it either like that or like that. Both are same, right? Now, coming to another part. As we have seen, this is benzene, where it has hydrogen. When one hydrogen is removed, right? When one hydrogen is removed, and it is, that means these all the places hydrogen is intact as it is, but here one hydrogen is removed, then the name of such group is known as phenyl. Make it a point to remember it. Phenyl. Whenever I say in the future phenyl, phenyl means a benzene ring but without one hydrogen atom. Take for example a benzene ring. Here all hydrogens are present, but here one, instead of one hydrogen is removed and it is replaced by CH3. Shit. हेलो, क्या है? नहीं, मैं घर पे नहीं हूं, बाहर हूं मैं लेक्चर में. So this is benzene with one methyl. So it's toluene, which is a common name, no doubt. But if this same structure comes in exam to mention the IUPAC name, so I will take this as a parent. So it will be known as methyl benzene. So here a methyl group is attached to a phenyl ring. Methyl group is attached to a phenyl ring. So always you remember, see, C6H6 is benzene, but C6H5 is phenyl. Always remember, it's very important. Whenever you hear phenyl, that means it's benzene without one hydrogen atom. Fine? Now, another very important concept. Suppose here it is some methyl is present, no doubt. Now, this is the first carbon atom. Now the next carbon atom. This is 1. The second carbon atom, which is this. This is 3, this is 4, this is 5, and this is 6. The second carbon atom is also known as ortho. Ortho. So if I go from here, this is second. If I go from here, this is also second. So I can say this is also ortho. Right? That means 2 and 6 both are ortho carbon atoms. 3 is known as meta. That means 3 and 5 both are meta positions. And para is just single 4. This is para. 4 is para. 4 is para. Right? So this is very important. This is ortho, this is meta, and this is para. Just make it a point to remember. In future, the name is going to come very frequently. Ortho, suppose if here there is a functional group, that means a phenyl group, a functional group is apna, sorry. A branch is attached to a phenyl ring. Now, ortho, meta, and this is para. A very, very common type of naming will be coming in future. Henceforth, ortho, meta, para, ortho, meta, para. Fine? Right. Now, we'll go with some few examples of it. Take for example this. So this is the main functional group, ketone. So at the first functional group, we have, suppose we'll start the naming from here 1 and this is 2. Okay? So this is, so at the first position of phenyl ring is added. So this becomes a substituent and this is the primary parent. Primary parent. So it will be 1 phenyl, ethane, 1 one. 1 phenyl, ethane, E is replaced by 1 one. 1 one. So 1 phenyl, ethane, 1 one. Right? This is the IUPAC name. Common name happens to be acetophenone. One phenyl, ethane, 1 one. Then this happens to be this. Now there are few functional groups having carbon atom carbon atoms, but attached to the ring. Directly. Which are the functional group? It's very easy. CHO, COOH, ketone, then COCl. Okay? Now, we'll see some few examples. Take for example, this and this CHO is there. The common name IUPAC has told it as it is known as benzaldehyde. But if I want to name the IUPAC name, this will happen to be benzene, which is a substituent, and this is seen as, if you see the table in which in the previous lecture I have told what is the prefix and the suffix of all the functional groups. Now, this is the main primary functional group and this is the substituent. So we have to use the suffix. So it is benzene carbaldehyde. Benzene carbaldehyde. This is the IUPAC name. Make it a point. Benzene carbaldehyde is the IUPAC name. Similarly, suppose this is CN. Here I forgot to write CN also. CN is directly attached to the benzene ring. As per IUPAC, this is benzonitrile. Benzonitrile is the common name, but this is benzene carbonitrile. This is the IUPAC name. Just don't forget, this is the suffix. This is the suffix because these CN, CHO are primary functional group, or you can say primary carbon chain, right? Primary functional. So they have to be given the first preference. Another example we will see. Suppose a benzene ring to which COCl is attached, right? The IUPAC, so the common name is benzoyl chloride. Benzoyl chloride is the common name, but this is benzene carbonyl chloride. Benzene carbonyl chloride. Right? Benzene carbonyl chloride. Benzene carbonitrile. Benzene carbaldehyde. Fine? Right. Now we will see one more example. COOCH3, suppose. COOCH3, that means it is an ester, right? So this is an ester, so it is methyl benzoate is the common name. Methyl benzoate is the common name, but what is the this? Methyl benzene carboxylate. Methyl benzene carboxylate. Just go through the table in the previous lecture where I have told the prefix and the suffix of each and every individual functional group. So methyl benzene carboxylate. Methyl, why first come? Because the whatever the group which is attached directly to this carbon, this oxygen atom, the name will be taken. The preference will be given here first, right? Methyl benzene carboxylate. Methyl benzene carboxylate. Now, we will see with now since we have seen maximum of this. If you want another few example, we will take. Take for example, we will see OCH3. OCH3 is nothing else. The functional group is ether. Ether, right? So now suppose if I want to give a UPSC अपना common name, I will say methoxybenzene. Methoxybenzene or methyl phenyl ether. So sorry, as previously I told, it was a slip of tongue. This is methoxybenzene, which is a IUPAC name, methoxy, because ether OCH3 is known as oxy, methoxy, alkoxy as we have said. So it will be methoxy benzene is the IUPAC name, while this is happens to be the common name. Methyl phenyl ether. Right, now we will see a few examples where there is no carbon atom, just normal. NH2 is known as aniline. These are important things. Aniline. Then take for example here COH. No, I will say benzene 1,2 dicarboxylic acid. Dicarboxylic acid. Benzene 1,2 dicarboxylic acid. Fine. Now, a few more examples we will try to take it. Few more complicated examples. Take for example, this is CHO. This is CHO. This is Br, and this is COOH. Now the primary functional group happens to be this. Fine. This has to be given the primary functional group. So 1 here, then 2, then 3, then 4, 5, 6. Okay? Now, this is the substituent. So this is bromo. This is also substituent. If you see our this, if CHO becomes a suffix, then it's al, and but if it becomes a prefix, if it becomes a substituent, then it is known as formyl. Now the numbering I have done it, but now how the naming I'll be doing. So it will be, since bromine is coming first, so it will be 3 bromo, 5 formyl, 3 bromo 5 formyl benzoic acid. Or you can also say 3 bromo 5 formyl benzene carboxylic acid. Carboxylic acid. Right? 3 bromo 5 formyl benzoic acid or benzene carboxylic acid. Now, we'll see one more example. Suppose this happens to be CHO. This happens to be CONH2. and this happens to be Cn. Fine. Now the naming we see as per priority order. CONH2 has to be given the first preference, and after CONH2, since the branching now comes here, second position is the branching. The understood is the counting has to go here like that, not here, because here the branching is at third carbon atom. So 1, 2, 3, 4, and then 5, and then 6. Fine. No. So it will be 5-cyano, 2-formyl, 2-formyl benzene carboxamide, 5-cyano 2-formyl benzene carboxamide, right? Benzene carboxamide. You can also say 5-cyano 2-formyl benzamide. Now that depends. Suppose if in your exams, if they give both the names, if they even say carboxamide or if they say benzamide, then carboxamide is better because that is much more closer. You will say here you are saying carboxamide is also correct, benzamide is also correct, but carboxamide is much more given the first preference. It is given the first preference because benzamide can also be used as a common name, but carboxamide can't be used in a common name. It has to be given in a IUPAC name only. So if both the options are given, then you go for carboxamide. If both options are not given and only 5-cyano 2-formyl benzamide is given, then go for this benzamide, right? 5-cyano. But if both are given, then go for the more precise carboxamide, right? Yeah. We will take some few more example. Which example? Take for example, I will take here one. Suppose if I write here Cn, then here we will take COCS3, and then here it is OH. Right? Now, who has to be given the first preference? Now this is ester, obviously this, right? And then this is a substituent, this is a substituent. This happens to be hydroxy, this happens to be cyano. The understood numbering has to go from here to here. 2, 3, 4, 5 and 6. Fine? Now, it will be 3 is attached first. So it will be methyl 3-cyano 5-hydroxy benzene carboxylate. Or also you can say benzoate. Benzene carboxylic acid or benzoate, right? No. Fine. Similarly, suppose O-C double bond O-CS3. Now this is also ester, C double bond C-O-O-R means phenyl. Now since this O is directly attached to phenyl, so the name of phenyl will be coming first. As in this case, O was directly attached to methyl, so methyl name came first. Similarly, so phenyl ethanoate. Or also you can say phenyl ethanoate is the more precise answer. Phenyl ethanoate will be the only answer, because it can't be phenyl benzene carboxylate, because if you say phenyl benzene carboxylate, so it becomes, it's not possible, because two things, both phenyl and benzene name can't be there at the same time. Fine. Now some more examples we will see. Fine. Now, suppose now we will take a very complex this. Suppose now COBR ले लो. यहाँ पर you take suppose OCH3. ठीक है, यहाँ पे OCH3 ले लीजिए और यहाँ पे आप ले लीजिए COOH एसिड सपोज, और यहाँ पर you take CHO, right? Again you take OCH3 and here you take OAT. Fine. Now, who will be the primary functional group? This will be the primary. That means the name is going to start from here. The rest other will be substituent. Now, what is COBR will be known as? It will be known as bromoformyl. Okay. And this will be known as methoxy. Then this will be known as ethoxy. Again, this will be known as methoxy. And this will be known as formyl. As usual. Now, the numbering we have done. Sorry. Now, since bromine, B is the alphabetically B comes first, so the numbering has to go like that. Not even the because from here the branching, from here also second position branching, here also second position branching. But then if both the branching comes at the same position, then we'll have to go to the another differentiating factor. It happens to be the alphabetical. So we are going like that, right? So it will be 2-bromoformyl, 2-bromoformyl, 4-ethoxy, 4-ethoxy, then 6-formyl, 6-formyl, then 3, 4, 5, 5-methoxy, 5-methoxy, again then 3-methoxy, carbonyl, 5-methoxy, sorry, 5-methoxy, 3-methoxy, suppose benzene carboxylic acid, benzene carboxylic acid, or benzoic acid, we can also say that, right? Everything has come. 2-bromoformyl, 4-ethoxy, 6-formyl, 5-methoxy, 1, 2, 3, 4, 5, 5-methoxy, and 3-methoxy, or you can also say 5,3-dimethoxy also you can say, 5,3-dimethoxy we can say, benzene carboxylic acid, right? Benzene carboxylic acid. Right? Just once again we will do it. Same thing, 2 bromoformyl, 4 ethoxy, 6 formyl, 5 methoxy, 3 methoxy, benzene carboxylic acid. So just make one change. It was a small mistake from my part. Everything remains the same. 2 bromoformyl. So it does not. It makes very awkward. 5 methoxy, 3 methoxy. Rather than that, you write 3 5 dimethoxy. Just make a change, please. Sorry for that. 3 5 dimethoxy. 2 bromoformyl, 4 ethoxy, 6 formyl, 3 5 dimethoxy. 3 5 dimethoxy benzene carboxylic acid. This is the final answer. So if this same compound comes into exam, then what will be the this 2 bromo, I'll write once again, 2 bromo formyl, 4 ethoxy, 6 formyl, 3 5 dimethoxy benzene carboxylic acid. Carboxylic acid. Fine. This is the final and the correct answer. This also was correct, but just it does not make sense. 5 methoxy and then 3 methoxy. Rather than that, it is 3 5 dimethoxy. 3 5 dimethoxy. Fine. This is the correct answer. Okay. Now we have done nearly everything. Fine. Now we will see that if in a unbranched, now up till now that was branched, right? That means all the benzene rings in which benzene ring was taken and to that functional group was directly attached. Now suppose if it so happens that if it's a unbranched alkane which contains at least 3 functional groups, which carbon based functional groups are directly attached to that alkane, directly attached, then how will you name it? Take for example CH2, CH2, CH2. Take for example here happens to be COH ले लीजिए, यहाँ पर COH, यहाँ पर COH. So obviously this happens to your longest carbon chain. ठीक है? So this becomes the parent carbon chain. ठीक है? So it will be, sorry, propane 1 2 3 tricarboxylic acid, tricarboxylic acid. Propane 1 2 3 tricarboxylic acid. Suppose like that, if it is CHO, this is CHO, fine. So it is propane 1 2 3 tricarbaldehyde. Tricarbaldehyde. Similarly, suppose COET, and then COED. Then since now to this O directly attached is this alkyl group, so it will be triethyl. Triethyl 1 2 3 1 2 3 tricarboxylate. Carboxylate. Fine. Now suppose if we have the same thing in a so this as we have done. Now suppose it is in a cyclohexane format. Take for example COCl. Now then it will be cyclohexane carbonyl chloride. Carbonyl chloride. Right? So this, I think so, enough IUPAC nomenclature we have done. And if you go through this, my previous lectures, last 3 lectures if we go, that means 5, 6 and this 7. 3 lectures if you see, quite a bit, then nearly 90 to 95% of the whole IUPAC nomenclature you can easily understand. And if you repeatedly see the lectures, you can easily understand it. So, and this nomenclature is the most important part, is very important part, because depending upon the names of the particular functional group, or sorry, a particular compound, future chemical reactions when you will see the different chemical reactions, in that the same type of IUPAC nomenclature is used. Right? Now we'll go to the next topic. Isomerism. Isomerism. Now, isomerism to some extent we have studied in class 9th and class 10th. Isomerism. So I will say first we should know, what do you mean by isomer? Isomer indicates compounds having same molecular formula but different physical and chemical properties. Physical and chemical properties. Or you can say and or anything. And or. It's not always that physical and chemical properties are different, right? So physical and or chemical properties, right? Right. So these are known as isomers. These are known as isomer. And the phenomenon is known as isomerism. Right? Isomer is what? Compound having same molecular formula but different physical and or chemical properties, right, is known as isomer, and the phenomenon is known as isomerism. Now, in isomerism there are basically different types of isomerism, right? Just for example, suppose if we write isomerism, in that we will see most important, this will be structural isomerism. Right? Or structural isomerism is also known as constitutional isomerism. Constitutional isomerism. Right? Now, in structural isomerism also there are many. It will be chain isomerism or position isomerism, functional isomerism, then tautomerism, then ring chain isomerism, ring chain isomerism, and then last but not the least, Metamerism. So structural isomerisms are of very different type, different types. Chain isomerism, positional isomerism, metamerism, functional isomerism, tautomerism, and ring chain isomerism. That means 1, 2, 3, 4, 5, 6. 6 types of structural isomerism. 6 type of structural isomerism. In detail, we will see in the further lecture, further part of the lecture. Right now, we will see for now the second part is known as stereoisomerism. 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 Stereoisomerism, there are only two types. First is known as configurational. Configurational isomerism, and this is conformational isomerism. Conformational isomerism. Conformational isomerism, configurational isomerism. Conformational isomerism and this conformational isomerism and configurational isomerism, right? Yeah. Now we will see first in that particular structural isomerism. What do you mean by structural isomerism? Structural isomerism, it's very simple. It excuse me, it has same molecular formula, right? Compounds having same molecular formula but different structural formula. Fine, different structural formula. Same molecular formula but different structural formula. Now, for example, take for example, we will see this is OH, which is known as ethanol. That means it is C2H6O. This is also C2H6O. Right? So you can say same molecular formula but different structural formula is known as structural isomerism. Known as structural isomerism. Now you will see there are compounds who show structural isomerism, chain isomerism, many more different. A single a pair of compounds, same compound, will show many different types of isomerism. But which isomerism has to be given the first preference also I will tell you in the lecture. Now we will see different types of structural isomerism, right? First is chain isomerism. Chain isomerism. Now, what do you mean by chain isomerism? Chain isomerism is same molecular formula but different property. But why different property? Due to different number of carbon atoms. Make it a pointer what I'm saying. Same molecular formula but different properties. Why? Due to different number of carbon atoms in the main chain, present in the main chain, or arrangement, you can say, also you can say arrangement carbon present in it. One present in it. Don't get confused. I will explain you. Same molecular formula but different properties. Why? Different DIES. Different properties due to the different number of carbon atoms. Different number of carbon atoms in the main chain. Try to understand. Two compounds having same molecular formula but they differ from each other in the number of carbon atoms which are present in the chain. That means, or the arrangement of carbon atom is such that in both the chains are different. So that is known as chain isomerism. For example, now as we know, what do you mean by a take for example C, right? Take for this is butane. I will say this is N-butane. Now, suppose the same N-butane can be written as C and this C, right? 1, 2, 3, 4. Right? This is CH3, this is CH2, this is CH2, and this is CH3. Again, this is CH3, this is CH, this is CH3, and this is CH3. Right? So 3, 3, 6, 3, 9, and 1, 10. C3H10. Here 3, 2, 5, 2, 7, and 3, 10. Sorry, extremely sorry. It's not C3, C4. C4H10. This is also C4H10. Fine. Here there is a straight chain. And here there is a branched chain. What? Branched chain. Why? What do you mean by branched? Branched means whenever a carbon atom is surrounded by minimum 3 carbon atoms. Whenever a specific carbon atom is surrounded by 3 carbon atoms. Take for example, this carbon atom is surrounded by this carbon. Surrounded means it is attached by another third. Means a specific carbon atom when attached to 3 different carbon atoms. Minimum 3. Max it can be only 4. Not more than that because carbon atom has 4 valency. Right? So minimum 3 and maximum 4. Then it is known as a branched chain. So here the butane is a branched. Right? So it has same molecular formula but as I have told you, differ in the number of carbon atoms in the main chain. Here the main chain has 1, 2, 3, 4. Here the main chain has 1, 2, 3. That means differ in the did you understand this? Or the arrangement of carbon atoms. 1, 2, 3, 4. 1, 2, 3. Right? Or arrangement of carbon atoms. Right? I hope you might have understood this. N-butane. This is N-butane, or you can say 2-methyl propane. 2-methyl propane, or whenever a methyl group is attached to a second carbon atom. One, as you know in the previous previous lecture, whenever a methyl group is attached to a second carbon atom, then it is known as isopropane also you can say. At the second position when methyl group is attached. Second position, a methyl group, then it is also known as isopropane. So I hope this you have understood. I will take some more examples so that you can understand much more easy. Right? Now, take for example, prior to that, see, CH4 obviously is not going to show any chain isomerism. Even ethane, CH3, CH2, CH3 is also apna sorry, CH3, CH3 will also not show chain isomerism. Even CH3, 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 that is propane, will not show chain isomerism, because I have told you what do you mean by branch. When a specific carbon atom is directly attached to 3 carbon atoms, here it is attached to 2 carbon atoms, here it is attached to 1, and here there is no. So C1, 2, 3, C1, C2, C3. These three will not show chain isomerism. Not show chain isomerism. So to show a chain isomerism, minimum 4, that is butane. Only butane is going to show. Butane or more than butane will be showing this. Now, same thing can be shown even by the aromatic compound. It's also very simple. Basically, if I say CH2, CH2 and then CH3, right? Then this also can be this. CH3 and then CH3 and this is CH. At the second position it is the phenyl ring. At the second position it is the phenyl ring. Similarly, suppose if there is a 1, 2, 3, 4 and 5, right? This thing also can be written as 1, 2, 3, right? 1, 2, 3, 4 and 5. 1, 2, 3. That second position again the methyl group has come. So I can say this is an iso. You can say 5 means isopentane. I will say it. So this can also be when one carbon atom is attached to 4 different carbon atoms. That means, right, that is 4 different methyl groups, 4 methyl groups. So this is known as neopentane. Right? CH3, CH2, CH2, CH2 and CH3. Similarly, CH3, CH2, CH2, sorry, this is CH, this is CH2 and this is CH3. Right? So isopentane and neopentane. And this is N-pentane. This is N-pentane. So these three are chain isomers. Fine. Now, we will go to the another type of isomerism, which is positional isomerism. We'll just see what do you mean by positional isomerism. What do you mean by positional isomerism? Positional isomerism, it is the same thing. First thing, it has the same molecular formula, but different properties. Why? Due to difference in position of either a functional group or you can say multiple bonds or branched chain. Try to understand. Same molecular formula but different properties. Why different properties? Due to difference in position of a functional group or multiple bonds or branched chain. For example, we will see an example of it. Take for example COH. Fine. So at the first carbon atom there is the presence of an hydroxy group. It can also be written as CCOH, C and C. Fine. Now it is at the 1 and 2 because this is the branching, so naming has to be started from here. Now the molecular formula of both these are same. Both these are same, but here the functional group is at the second position and here it is a. So I can say these are positional isomerism. Or this is also a straight chain. This also is a straight chain, but the position of the functional group is different. Similarly, we can say right double bond ene. Ene is present at the first carbon atom. It can also be present at this. Now it is present at the second carbon atom. So these two are positional isomers. Positional isomer. Fine? Now, take for example, I think so we have done a little bit. Now I will try to stop here only, or else it will become too much. So in the next lecture we will take some more few examples of positional isomers. I hope you might have understood this isomerism which I have started. Okay. In the next lecture we will see more positional isomerism. Right. I hope you are understanding this, my continuous lectures which I am taking. If at all any doubt or this, you can either write in the comments or you can easily email me also. Email me. The email is which is given. The email address is given in my description. Or you can also Twitter me, or you can also write in a WhatsApp me. I hope you have understood it. I shall take a leave. Right? So meet you in the next lecture. Possibly. Right? Okay. Bye. Thank you. Thanks a lot. Namaskar.